Now we go to the next set of formulas for simple substitution integration. Integration by simple substitution. Okay, so what if we are given, okay, the integrands which look like this, okay, wherein you cannot simply use let u be equal to something and then it follows the I1 to I14 format. So we have these additional formulas. Okay, so for example, no, we have 9 minus 4x squared. So if we let u be equal to 9 minus 4x squared, so obviously there's no du. We cannot form the du. So we cannot also let u be equal to just 4x squared because the derivative is 8x and there's no x, okay, in the given integrand. So we cannot use I1 to I14. Okay, so we'll use these formulas here, where a, by the way, is a constant and u is a differentiable function of x. So not just any function of x, it needs to be differentiable. If not, then you cannot use the formulas. Okay, so for the first three, so it's resulting to the arc sine, arc tangent, arc secant, or meaning the inverse trigonometric no, functions. Yeah, for the next set, we have logarithmic generally. Okay, logarithmic, except I-21, which has inverse trigo. So it needs to be in the form a squared minus u squared or a squared plus u squared. Basta it should be a sum or difference of two squares. All right. So our target is, there's no radical here. So 9 is a constant and 4x squared is a function of x. So our target is a squared minus u squared. Okay, so let's look for that formula. Okay, so obviously again, it's not a radical. Wala, may square root din ha. Okay, so a squared minus u squared is I-19. Okay, so we need to solve for a and for u so that we can use the formula directly. So if a squared is equal to 9, so let me write that here. So if it follows a squared minus u squared, therefore a squared no, is equal to 9. So a is square root of 9 or 3. Then u squared is 4x squared. So u therefore is square root of 4 is 2. Square root of x squared is x. And then du is 2 dx. So there is only a dx. So we need a neutralizing factor of 1 over 2 or 1/2. No, the reciprocal of 2. The missing factor to form the du. So we can now write this in the form. Now don't forget the neutralizing factor. So it's already in the form du and then over a squared minus u squared. So according to the formula, it's 1 over 2a. Okay, I-19, 1 over 2a, and then times the natural log of a plus u all over a minus u, then plus c. So according to I-19, so let me put the equal sign here instead of the ma-align no, because na ani. Okay, so 1 over 2a multiplied to the 1/2, by the way. Do not forget the constant outside. So 1 over 2a, so 1 over 2 times, so a is 3, okay, times the natural log of a plus u. So that would be 3 plus 2x. Okay, u is 2x. And then over a minus u, 3 minus 2x, and then plus c. Again, this is using I-19. So simplify, it's 1/2 times 1 over 6, so that's 1 over 12. Okay, times natural log of 3 plus 2x. Okay, all over 3 minus 2x. And then plus c. All right. So second example is, okay, if we have the x over x squared minus 4x plus 8. So it's not a difference of two squares though, or sum of two squares. Okay, there are three terms. Okay, but we cannot use I1 to I14 because if we let u be equal to x squared minus 4x plus 8, then du would be 2x minus 4. Obviously, there's no 2x minus 4 here. So, we try to transform this into sum or difference of two squares. And then there's no radical. So, maybe same with number 1, a squared minus u squared, or it can be a sum of a squared and u squared. So maybe I16. Okay, so let's see. So the target is for it to be transformed into a squared and u squared, whether plus or minus. Okay, so recall in algebra that we can transform a trinomial into a square of a binomial if it's a perfect square, not trinomial. Okay. Recall the special product formulas na if you have x minus y, if you raise that to a power of 2, it's the square of the first term minus 2 times the product of the first term and the second term, and then plus the square of the second term. So if the binomial is x plus y, so all terms would be, or all operators are addition. Okay, so these trinomials are what you call perfect square trinomials. Okay, so we can see that it's a perfect square if the first and third terms are obviously squares, and then again the middle term is 2 times x times y. So x squared is a perfect square, and 8 is not a perfect square. No, square root of 8 is not a whole number. Okay, but we can get factors for 8. We have 4 times 2, where 4 is a perfect square. So let's see if we can transform it to square of a binomial. So we got a minus 4x here. So maybe it's x minus y. Okay. So to get the last term, to get the y squared here, so we divide the middle term by 2x. And then we square the result. So 4x, we divide this by 2x. Okay, it's equal to 2. And if you square it, so we need a 4. Okay, so there's no problem because we have a plus 8. You can always um, factor out 4. I mean, not factor out. Get 4 no, from 8. So if we are going to get 4 from 8, so 8 now becomes 4. Okay, so this 8 here can be written as 4 plus 4. And this would form the perfect square trinomial, which can now be written as x minus y, quantity squared, because x squared is the square of the first term. So meaning the first term of the binomial is x, and then it's a minus because the second term is a minus, no, minus 4x. And the last term of the trinomial is 4. Square root of 4 is 2. Okay, so it's x minus 2, no, quantity squared. So the middle term is 2 times x times 2, or that's 4x, which is the middle term no, in this trinomial. So it's really a perfect square trinomial. And then no problem with the 4 because you can write it as 2 squared, right? So basically, the format is a squared plus u squared, where a no is x minus 2 and u is, or rather, this is u squared. Sorry, this is a squared because a is a constant, okay, and u is a function of x. So u squared plus a squared. Anyway, you can, of course, interchange the terms because it's this one, okay? So u is x minus 2, du is dx or 1 dx, no, or dx. A squared is 4, or you can just write a as 2. So no need for a neutralizing factor. Okay, it's equal to, okay, so it's here. It's in the form du over u squared plus a squared. So it's I 16, I think. Okay, sum of, oh, oof, sum of a squared and u squared. All right. So again, we can write it as u squared plus a squared no, because it's addition. So 1 over a times arctangent of u over a plus c. So according to I-16. Okay. Take note of the reminder ha na if the variable of integration is u, then you should be consistent with the functions. It must be expressed as au and not another variable. Okay. So it's 1 over a according to I-16. So 1 over a. So a is 2. Okay. And then our tangent of u over a. So u is x minus 2. And then a is 2. Then don't forget the plus c. Okay. So this is the final answer. So the third example. Okay. So you have a 4 here. It's a constant, so we can just always put it outside. And then, okay, so we have a radical. So our target is, this is the u squared and this is the a squared, but we have a y here, a function of y. So let's see, inspect nato from the formulas. What's the possible format? Okay, so there's no function of x here or u here outside the radical. Okay, so it's probably I-17, no? Because there's a function of x here, function of the variable of integration here outside. So there's no other formula now we can use because here there's no u outside, and here it's obviously not in the denominator. Okay, so it must be I, no? 17. So again, our target is I-17. So the u squared would be the 25 y squared. Okay, so meaning u is 5y. So we need a 5 dy for the du. So we need a 1/5 for the neutralizing no, factor. And a squared is 16. Therefore, a is 4. Square root of 16 no, is 4. And then for the y here, okay, we can replace it with this. We solve for y no, from this equation. So let me put it here below. So y is u over 5, or 1/5 y, 1/5 u rather. Okay. So everything must be transformed into the new variable, no? So u, take note, no, we cannot combine two variables, okay, in just one integral. Okay, we can do that if we go na to multiple integrals. All right, so we transform everything to u. Okay, so no problem with the 4 because again, it's a constant. So according to, I think it's property number 2, no, for indefinite integrals. So you can just put it outside. Okay, and then don't forget the neutralizing factor 1/5. So meaning dy becomes 5 dy since we already placed the neutralizing factor outside. So becomes 5 dy here. So it's transformed to du. And then the y is u over 5. Okay, and then the radical becomes square root of u squared, no, minus a squared. Now, just to show that it's in the same format, no, with what was that? I 17. So this is u over 5, then there's no problem. It's just an over 5, so it's a constant. So it's 4 times 1/5, okay, divided by 1/5. So meaning we end up with a 4, right? Times the integral of du. And it's now in the form u square root of u squared minus a squared. So I 17. So according to I 17, it's an arc second. Okay, the integral is an arc second. So it's 1 over a times arc second u over a plus a. Plus c, rather. So look at the pattern. So there's no 1 over a if it's arc sine. Okay, so 1 over a arc second of u over a plus c. So we get 4 times, okay, here, rewrite that. 1 over a, so it's 1 over 4. 1 over 4 times arc second. So if you want to use the negative 1 power, okay, for arc second, so you can also do that. So u over a, so u is 5y and a is 4, then plus c. Mhm. So 4 times 1/4, it's just equal to 1. So basically, the final answer is arc second of 5y over 4, and then plus c. All right, so that's the special set of formulas. Okay, so later on, when we go na to the other methods of solving integrals, now wherein we cannot simply use these formulas. Okay, so we will compare our answers later. Okay, so we can actually derive these formulas from those methods: algebraic substitution, trigonometric substitution, etc. Okay, so that's for I 15 to I 22.